Okay, in this chapter we're going to talk about the mole. First person we need to talk about is Avogadro. So Avogadro's number is named after him. He didn't come up with this number, but it was named after him because he did a lot of research in chemistry. So he was given credit for his work in chemistry, determining the difference between atoms and molecules. And we know what the difference between atoms and molecules are. Atoms have one element in them. Molecules are two or more elements chemically combined together. Next thing, reactants form products. In the last chapter, we looked at equations, we balanced them, and that was kind of all we did with them. In this chapter, we're going to use these equations to then figure out, well, all right, how much water can we actually make if we have some hydrogen and some oxygen? So that's the main purpose of this chapter, is how much water or how much of a product can we make if we have a certain amount of the reactants. So first thing we have to do here is we need to balance this. So we have H2, O2, H2O. On the right side, we only have one oxygen. Here we have two. So let's put a 2 in front of this. All right, so now our oxygens are balanced, but we can see we have 4 hydrogens over here. So we need to put a 2 here to balance that out. So this is a ratio. If you have 2 hydrogen gas particles, 1 oxygen, you can make 2 water molecules, all right? Now that's just for one time. So like if you just had 2 of these and 1 of these, you can make 2 waters, all right? Let's say we have 100 times this. So let's say we have 200 of these hydrogen gas particles. We have 100 of these oxygens. How much water can we make? Well, the ratio tells us we can make 200. And that's kind of what we're doing in this chapter. But you would not be able to see just 2 molecules of water. You wouldn't even be able to see 200 molecules of water. We need large amounts for us to be able to see it. So there's this number that represents a large amount, and it's this right here, this 6.02 times 10 to the 23rd, all right? Huge number. Now, if we had this much water in our hand, we'd be able to hold it. It would be able to fit in our hand. Oh, in one hand, we could probably hold that much water. So it's not a lot, even though there's so many molecules in there. Now, to do the ratios, though, we need this number, but we need 2 times it. So we could say, all right, we need 2 times that number. All right. For this one, we just need 1 times it, so we could just write the number, 6.02 times 10 to the 23rd. All right. And then for the water molecules, we need 2 times it as well. All right, so that's how much water we would be able to hold in our hand. We could drink it. It wouldn't be that much water. Okay, so this is kind of what we're starting with ratios in this chapter. Now, counting is one way to express how much of something you have. So if you have 12 apples, we could turn that into another word that we know. We could say that we have 1 dozen, right? 1 dozen apples equals 12 apples. So if we have 6.02 times 10 to the 23rd apples, we would actually have 1 mole of apple. Now this seems a little crazy. 6.02 times 10 to the 23rd apples, that's a lot of apples. If we had that many apples, it would be larger than the size of the earth filled with apples. So that's an insane amount of apples, all right? But this is much easier for us to think about, 1 mole equaling this large number. So that's why we came up with this abbreviation. Look at me saying that we came up, as if I came up with it. Anyway, the reason that they came up with mole was not because of the animal, it's just short for molecule. So that's kind of the idea behind that. You can even shorten this even more and just say 1 mole without the E, which I usually do. So you'll see that a lot this year. Okay, so let's talk conversion factors. So you know, if we were talking about like centimeters and meters, you know that 1 meter is 100 centimeters, right? Well, that's basically what we're coming up with mole. We just have a new number. So 1 mole equals 6.02 times 10 to the 23rd. All right, it's helium, so it's helium atoms. because helium is an element, so we say atoms. And then if we take a look at this, we have 6.02 times 10 to the 23rd. We're talking about water here, so we would say H2O, and H2O is a molecule, so we have to write molecules. All right, so 6.02 times 10 to the 23rd water molecules would be this one. But it's the same idea as if you see centimeter, you think 100 with a meter. Now, whenever you think of 1 mole, you're going to need to think of this number, which means you need to memorize it as soon as possible, so you always have that in your head.